Hello, let's continue our Sudoku adventure with Galactic Adventure by GDC. So, this has spiral galaxies in it, which I don't think we've had on this series before, which is surprising that we can still have new constraints after over 800 puzzles, but here we are. So, let's go over the rules. We do have normal 6x6 Sudoku rules, so in each row, each column, and each 2x3 box, we are placing the digits 1 to 6 exactly once each. All right. So we're going to be drawing galaxies in the grid. I'm just going to pick somewhere random for now. Let's say this is the center of our galaxy. We need to be able to rotate the galaxy 180 degrees and have it be identical. So it has to be symmetric over the 180 degree rotation. So this would be an example of a galaxy, kind of a spiral galaxy here, that is symmetric, right? Because if this is our center, then these two, when we turn 180, go here, and these two, when we turn 180, go here. So it's exactly the same. It occupies exactly the same cells when rotated 180 degrees. Another example would be just here, one cell. That's a galaxy. Or we could do like a block of 4 cells. That's symmetric around this center here. So there's a lot of ways we could draw it. We could draw something like this. We could draw something like a straight line down like that. That would be a galaxy. And its center would be between these two cells. All right. Now, how do we find our galaxies? Well, all of these diamonds are the centers of galaxies. Some of them, the centers are in a cell. Some of them, the centers are between cells. But that is going to be the center of all of our galaxies. All of the centers are given. So this is not, oh, sorry, not that one. This is not the center of a galaxy. This is also not the center of a galaxy because the center is actually between these 4 cells. In addition to that, we do have circles in the grid. The circles are only centers if there's a diamond in them. But every cell is, I guess I didn't cover this, every cell is in exactly one galaxy. So our galaxies don't overlap each other, and every cell must be in a galaxy, which has a given center, right? And so the circles will be in a galaxy, and whatever galaxy they're in, exactly the one galaxy they're in, it has the count of the cells in the galaxy. So if this was a 3, I don't know, maybe we'd have, okay, 3 is probably a bad example. I don't know. Yeah, we could do this. This would be a valid galaxy with a center and a diamond, and then a 3 in here because this is a 3 cell galaxy. All right. And I believe, the only other rule is digits may not repeat in a galaxy. So if I had a galaxy like, I don't know, like this, and we put a 1 here, we can't repeat a 1 anywhere in the galaxy. So we can't even put 1 here or here. All right, and that is it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself. And I'm going to get started right now. Okay, I guess I could start here. Let's make this green. So this is our green galaxy here. Why do I know that all 4 of these are in this galaxy? Well, we know this is the center of a galaxy. So we're going to need 2 cells at least to be symmetric around it. But it says that all of the galaxies are orthogonally connected. So we can't have them be diagonally connected like this. We'd have to fill in one of these 2. And once we fill in one of them, we need the symmetric one. So that's my proof that this does that. Now, I also think that this can't grow at all. Because if it grew to any of these cells, you can't even grow to other centers, but if it grew to any of these cells, the symmetric would be off the grid. This symmetrically would be over here, this symmetrically would be over here, this would be here, this would be here. We can't go off the grid. So this galaxy's done. It's a 4 size. I might as well draw this one as well. Let's just make this purple. So this galaxy could grow. I don't know if it must grow, but it could. It can't grow here. Let's actually think about where it can grow if it wanted to. So these are definitely not part of this galaxy. You know what I'm going to do? Just temporarily until we know how this galaxy moves, I'm just going to put black X's where it definitely can't grow to. It's not allowed to grow here or here either, which would be symmetric here and here. So I guess if it did grow, it would take exactly this cell and this cell. That would be the only way it would grow. What about this one here? Let's make that orange. This is the center of a galaxy, and it's on an edge, right? So we can't ever grow to the left. We can't grow down because it would invade this galaxy. So this is actually done, and it's got a circle, so this is a 1. So it does not grow there or there. I'll get rid of the X's once we kind of have more drawn. I guess I could think about, okay, yeah, if we give this a color, let's give it red. It's clear that it can't grow to this cell up here because the symmetric would be off the grid. So now the question is, because we know every cell is part of a galaxy, what galaxy is this cell in? It's not its own center. It's not a center, so it has to join a center, has to find a center, and the only way it can move is this way. It's not going up, it's not going down according to our X's. So we have to take that one and that one. And now we know that purple is done. So I don't think we need any of this. I guess we can draw that one. We know purple's done because it's 6 in size and it can't grow bigger, and so this circle is a 6. It's because you can't repeat digits in a galaxy. They can't ever be bigger than 6. Also, it's got a circle in it, and the circle is the count, and we can't put more than 6 in a circle. So there's 2 reasons. Now we've obviously got this galaxy here, and it can't grow anymore. It's not growing up, and if it grew left, it would invade red. So let's just call this yellow, and it's done. So I guess I could draw an X here. I could draw X's around this guy too. And here. Okay, I'll leave those in because we don't have those colored yet. Okay, I think there's a few questions we can ask, but actually I'm curious about this guy here. Let's give this blue. It is not the center of a galaxy, so it's got to seek out a center. So it has to grow, has to get out. So the only way to get out is there. And now it's, the problem is it needs to find a center. It could grab any of these centers. This one is, in my mind, I think this is the only viable one. So yeah, if we grew here, and then we took this center, there's a lot of problems with it, not the least of which is we would have to be moving off the grid in order to be symmetric all the way out here, but also it would be 7 cells in size because we already have 3 on this side of the diamond. And so, yeah, there's a lot of reasons we can't take that diamond. We definitely can't take this one for very similar reasons, and we can't take this one. Yeah, there's just no way. I mean, I don't even know if I had to prove that to you. It's definitely taking this diamond. And so the way that these are symmetric around this center is to take these 2. And now it's done. And actually, I would postulate that a galaxy with a diamond in the center is going to be odd in size, and a diamond with a galaxy between cells is going to be even in size. If it's in the cell, then every time we add another cell, we have to add its opposite on the other side. And so that's true of any center. And so however many cells the center is, that's the even or odd. So this is 1 cell in the center, so that's odd. So the whole galaxy is odd. This is 4 cells in the center, so that's even. This is 2 cells in the center, so that's even. Same here. All right. Anyway, that's a fun proof. Because every time you add 1 cell, you have to add another one. So this doesn't grow at all across these. I don't know how helpful these X's are, but maybe. So this is a 5 because it's a circle. The circles are a little bit hard to see, but yeah, we should ask about this cell here because it's not the purple and it's not the yellow. So what's next on the docket? I guess green is next because we just made a blue. So this has to go somewhere because it's not a center. It's going to grab this, and that is a center. And so now this is the cell that's 180 around that center. So this is obviously a 1. It's its own galaxy. And so we can't grow any further. If we tried to go up, we would need a cell that was below the grid. And we can't obviously grow left. So there's nowhere to grow. So this is done. So this is a 4. And so we know these are all X's, and we don't need these X's anymore because they're colors adjacent to each other. All right. So this is all, we need brand new galaxies for all of these. I guess we could start here. This is, I don't know if I want to make it purple. Let's just skip purple for a second. Here, I'll make this one purple, and we'll make this one orange. I'm just going in order of my color palette. So this isn't going to grow. It can't grow up because it would need a cell below, and it's not going to grow right because it would need a cell to the left. So this is just 2 in size here. So we can make X's there. Now this purple, hold on, let's think about this cell here. Actually, maybe I shouldn't have made it purple. Let's make it red. All right. This cell here needs a color, and it needs a center. Once it comes up here, it's going to be orthogonally adjacent to this. It's not going to take this center. This is the only center it can take. A similar argument to this blue. I think it's pretty obvious. And so that's 180 symmetric this way. And it's done because it's an odd size. It's the biggest odd it can be. And that circle's in it, so that's a 5. I can get rid of all of these X's. And I do believe we just have one singular. This is just its own. I guess we can bring back purple. All right, that's its own galaxy right there. Cool, so we're done. It was the only center left, so I had to take the rest of the cells, and luckily that worked out. So we've seeded with some digits. This is a 2. I forgot to fill that one. All right, now I guess we just do Sudoku with non-repeat cages. So where does 5 go in this box? It can't repeat in the red, and it's not repeating in the column, so 5 goes there, and that puts the 5 down here as well. This is a 2-3 pair. So this is a 3-6 pair, and this is 1-4-5. That's not 1, that's not 5. All right. We need all digits in here. We need all of 1 through 6 in here. We have a 6 already. So 6 can't repeat in purple, so this has to be a 6. And so these are, we know what these are. These are, just for the box, 2, 3, 4, which means these can't be 4. So this is 1, this is 5, this is 4. That's not a 4. I keep thinking we've got like some sort of ratio dot or something across these, like I should like be able to propagate that, but no, there's no digit restriction across that. So over here we have the 1-6 pair. This 6 tells us that's 1, that's 6. Over here we have 2, 3, 4. That's not 4, that's not 4. So that's our 4. This is 2, 3. How are we expanding this? Maybe we need a 5 and maybe 5 and 6. Is it interesting that these aren't 5, 6? Maybe. I'm seeing that 6 isn't here and it doesn't repeat in blue. So 6 ends up over here, actually, in this box, which does point down, making this 3 and this 6. That gives us the 2 here. 3 in the corner, emitting graffiti. Very nice. Celebrating being a 3. This is 5, 6. Oh, yeah, and this 5 tells us that's 6, that's 5. What do we need over here? 1, 3, 4. It's not a 4. And over here we need 2, 3, 4. That's still not a 4. All right. Wonder what digit we're missing. Okay, this is missing the 1 because this can't be 1 and these can't be 1. So it's only missing 1 digit because it has 5 unique digits. So this is also 2, 3, 4. And so now where does 4 in blue go? It goes right there. That's not a 4. That makes this 3 and 4. It makes that 2, 3. That's 1 and 3. That was because of blue. That's 2 and 3. That's 2. That's 3 and 2. And now that's 6. That's 1. And we're done. All right. I mean, it took 9 minutes 25, but I mean, we had to draw the spirals and then we had to do the digits. So it's basically 2 puzzles in 1. So yeah, not bad. Really fun puzzle, GUC. I enjoyed that. Yeah, I don't think I've done a spiral galaxy puzzle in a really long time. So thanks for resurrecting that for me. So yeah, that's neat. Let me know how you did. If you enjoyed this, why not leave a like, subscribe, and a kind comment below.